make sure when you're buying those things that you're working with somebody who's going to help keep you out of the ditches in that regard. I've got a handful here, but everybody I think should throw their most egregious in the comments below. I think we could probably make a pretty good list. I think probably number one is combustion air issues. So the burner on the boiler or a water heater or any piece of fired equipment is going to mix fresh air and gas, and we have to make sure that the room has an adequate supply of fresh air so that we don't end up having draft issues from that fired appliance. So NFPA 54 tells us all the rules around the openings we need to allow this air in. And we very often see that violated. Typically with like a high pressure steam boiler, it's because they have a louver in the sidewall or a damper on the sidewall that can be shut while the boiler is running, and it won't shut the boiler off. And so then that boiler room runs at a very negative pressure, right? And so we're kind of starving that boiler for air. That can make the boiler run really rich. It'll make soot, but it also can cause some other problems like backdrafting boilers nearby or other equipment. Kind of the telltale sign is you go to open the door to the boiler room and the door is really hard to get open. That's kind of a pretty good sign that somebody either took a shortcut or didn't know any better, or somebody covered something up that they weren't supposed to cover up because cold air was coming in that louver or something of that nature. So combustion air is probably the biggest one, and maybe in no particular order. But next I would say e-stops by every door, right? So the code calls for every entrance to a boiler room to have an e-stop so that we can shut those boilers off. And I think if you think about it, if a gauge glass was to break on a hot water or steam boiler and be filling that room with steam or a burn hazard, you may not be able to get to the boiler control panel to shut the boiler off or able to get close enough to that gauge glass to isolate it properly. So the code calling for that e-stop outside the room makes a lot of sense. So that's one that gets missed a lot, where if a room has two doors, they only put the e-stop on one and there should be one on both. Pretty simple thing to add. We've seen in some jurisdictions where they're now requiring carbon monoxide monitors in boiler rooms. And so in the places where that's recently been added, it's really common that we go into that boiler room and don't find a carbon monoxide detector. So it's important that we get those added so that if there is flue gas entering the room, that people are alerted and we don't have anybody dropping because of that. One that I see pretty commonly, it's not super common, but it's not rare either, I guess I'll say, is where somebody has replaced a valve on the boiler proper. So boiler proper would be the first valve from the boiler or the second valve on like steam or blow down or feed water. Any valves on the boiler proper, the code is very specific about what materials we can use. And 304 and 316 stainless are not allowed. And so I've seen a handful of times over the last couple of years where a customer has a blowdown valve or maybe a water column blowdown valve or something of this nature, and they've installed a 304 or 316 stainless steel valve thinking, well, this will last forever. The code specifically prohibits stainless steel in these applications because stainless steel can be susceptible to stress chloride corrosion cracking, and those valves can fail in a brittle way without warning. So it's kind of a big problem. So just make sure that as you're replacing valves or doing work on your boiler systems, that you have somebody that's familiar with the system, sizing and selecting your valves, or that you're buying them from a reputable supplier who knows where you're putting it, right? That you're getting the right thing. In that same vein, I've seen a number of times where people will install a safety valve that's rated for Section 8 vessels, not for Section 1 boilers. And while that seems simple, they have different formulas for the relieving capacities. And so at the very least, you could get red tagged for it. But worst case scenario, you wouldn't have enough relieving capacity and something really bad could happen. So make sure when you're buying those things that you're working with somebody who's going to help keep you out of the ditches in that regard. While we're talking about safety valves, I've seen a couple of times in the last year, I get a picture and a question of, hey, is this okay? Where somebody has taken the safety valves on a boiler and put like a 1-foot piece of pipe and then threaded the safety valve into this piece of pipe that goes down to the boiler drum, the top of a fire tube or the drum on a water tube. And the code has very specific rules about this. You're not allowed to have pipe between the safety valve and the boiler that's any smaller than the inlet of the valve, and it can't be any longer than the end-to-end distance of a T of the same size. Okay, what they're worried about is too much pressure drop in that line could cause that valve to lift, and then as the steam flows, It causes pressure loss, and so then the valve reseats. So we can get valve chatter that won't allow the valve to relieve the full capacity, and we could overpressure a boiler. So no extensions on safety valves. Best practice is just put them directly on the boiler on those connections. And if you need to have that piping run this way or that, then do that on the relief valve piping after the safety valve, and you should be fine. So just be careful about any extensions. We've got a couple of boilers where we're taking those out this year because somebody had added those at one time, and it's been that way 20 or 30 years, but that's not something where we want to pull the grandfathered in card. We want to just get it fixed and have it fixed right. The last one I'll say, and I see this pretty common, is where the gauge glass valves are not accessible from the floor. So if that gauge glass valve is more than 7 feet off the floor, then we need chain handles so that we can actuate that valve. But here I think common sense really prevails. If that gauge glass is leaking and I need to isolate it, I probably don't want to shimmy up a ladder and get that close to it to shut it off. So if it's that tall of a boiler that you can't walk up to it and stand off to the side and shut that valve off, then you're probably going to want chains so that you can do that from the floor. So yeah, that's kind of a common one where we have either hand wheel, either the quarter turn where it should have chains and the chains are gone, or it's a hand wheel type gauge glass valve and you just can't reach it. So those are just little things to get fixed, but it just makes the boiler room a whole lot easier to operate and a whole lot safer to be in. If you have some other ideas, put them in the comments. I'd love to see them, and we can start the conversation there.